This video is a quick review of how to factor trinomials. There are two methods we're going to cover for trinomials, both depending on the quadratic trinomial you start with. First of all, factoring trinomials when a equals 1. What are we talking about there? If you think about the standard form for any quadratic trinomial, ax squared plus bx plus c, we are looking at situations where the lead coefficient is a 1. So in that type of situation, we use a method called sum product, where you're going to be looking for two numbers that multiply to get one number and add up to the other. So in number 1, we notice we've got lead coefficient of 1 on my quadratic trinomial. Trinomials will always factor down into two binomials. So in the sum product method, x squared, that always comes from multiplying x times x. So your first term is always going to be x times x, or whatever variable you're working with there. So here's what we do and why it's called sum product. If I look at my c value and my b value, I need to figure out what times what gives me 36 and adds up to 15. So what you could do is you could list out every factor of 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. Okay, so 6 times 6. One last one there. Those are all the factors or numbers that multiply together to get 36. I don't need to worry about negatives in this problem because every term is positive. Which one of those factors add up to 15? Well, that would be 3 and 12. So I'm going to do x plus 3 and x plus 12. Because if you were, so I'm done factoring at this point. But it's x plus 3, the quantity x plus 3, and the quantity x plus 12. Because if you were to distribute this back out, and combine your like terms, you'll notice you will end up with the trinomial you started with. So that's one way you can always check your answer. You can always distribute out what you factored and see if you get your original expression. So let's start throwing some negatives into the mix here. Again, quadratic trinomial will always factor down two binomials. Lead coefficient's 1, so x times x in the front. What times what gives you 27? Now again, you want to try to add up to 12. First thing that comes to my mind is 9 times 3. Now I know adding 9 plus 3 gives me 12, but notice I want to add up to a negative 12. I got to add up to a negative 12. So another way to multiply to get a positive 27, it is not only 9 times 3, but negative 9 times negative 3 would also multiply to give me a positive 27. And when I add those two, I also get my negative 12. So if your c value is positive and your b value is negative, you're going to have that case where both of your factors need to be negative. Finally, for number 3 here, another sum product, x and x in front. Negative 45, I need to figure out what times what gives me negative 45. So one number has to be positive, and one number has to be negative. So with 45, I'm thinking right off the bat, 9 times 5. Maybe it's 9 times negative 5. Those are two different options. If I want to add up to a negative 4, looking at those two, I'm going to want to go with that pair because negative 9 plus 5 gives me negative 4. So minus 9 and a positive 5 there. You could also write it the other way with your quantities in reverse. It's the same thing. You could do those for any of these 3 problems here. As long as you got the 2 correct quantities, it doesn't matter which order they're written in. So that's sum product, that's factoring with a lead coefficient of 1. What happens if you've got a quadratic trinomial where your lead coefficient is something other than 1? We're going to look at this, a method. There are multiple methods you could use here, but we're going to specifically use one that you use in Algebra 2, and it's called split the middle term. Split the middle term is what the method is called. So here's how it works. In number 2, we're basically going to turn this trinomial into a 4-term expression. And If we remember, we can factor a 4-term expression using the grouping method. So we're basically going to turn these trinomials into a grouping problem. So to do that, you take your lead coefficient, multiply it by your C value. 2 times 6, that's going to give me 12. Now you want to list every multiple, or every factor that gets you 12. So that'd be 1 times 12, 2 times 6, 3 times 4. So those are all the products I can think of that give me a 12. And again, I'm not going to worry about negatives in this one because none of my terms are negative. Now, which one of those terms, which one of those products add up to a 7? Well, it looks like 3 plus 4 would give me 7, so here's what we're going to do. It's called split the middle because what I'm going to do is replace the 7x with a positive 3x and a positive 4x. So what I've done is I've split 7 into 3 and 4. And I got the 3 and 4 from the factors of my A term times my C term. So now that I have a 4-term expression here, I can just apply the grouping method. So now group the first two and the last two. I can factor out an x out of both of those. Out of my last two, I can divide both of them by 2. Oops. Notice again, remember when you're grouping, those two quantities need to be the same. So I would have x plus 2 times the quantity 2x plus 3. So that would be my factored expression. Repeat the process again. Let's do number 4 here. Number 2 has lead coefficient of 4. So 4 times 6 is 24. Everything that gives me 24. I want to add up to an 11, so that would be 8 and 3. So I would break this down into 4x squared. I'll split the 11 into a 4x and a 6x. Oh, I'm sorry. 3 and 8, not 4 and 6. 3x and an 8x, and the plus 6 on the end. And again, turn it into a grouping problem. First two can be divided by an x. GCF out an x there. Left with 4x plus 3. The last two are all divisible by 2. And that would leave me with 4x plus 3. So x plus 2 times the quantity 4x plus 3. Factored expression. Let's start working some negatives in here. Same process though, 6 times 15. 6 times 15, whoa, that's 90. So I've got 90 here. So now, 90, I notice I got a 19 in the middle. Pretty easy to find. You're probably going to want 9 times 10 there. Now notice it's a negative 19. I've actually got a negative 19 in the middle. Think back to when we did sum product. You can multiply two numbers together to get a positive number by doing positive times positive, but you can also multiply two negatives together to get a positive. So negative 9 times negative 10 multiplies the positive 90, also adds up to a negative 19. So now when I split my middle, minus 9x minus 10x plus 15. Your third term is negative here, so be careful when you do your grouping method. Plus sign in between, shove that negative in that second quantity. So I can divide out a 3x here. That would leave me with 2x minus 3. I can divide out, now notice, I want my second term to be negative here. Right now it's positive, therefore I'm going to want to divide out a negative. 10 and 15, biggest number that goes into those two is a negative 5. So that would leave me with a positive 2x here, negative 3 for the second term. That's what I want to match my first. So then my answer would be 3x minus 5 times 2x minus 3. One final example here. Split the middle term. So 3 times negative 6, that's actually a negative 18. So what gives me negative 18? Well, negative 1 times 18, which on the other end would be 1 times negative 18. Those are two different options, so make sure you list both with the negative on the first term and the negative on the second. So I can do negative 2 times 9, 2 times negative 9. I can do negative 3 times 6, and I can also do 3 times negative 6. I want to add up to a negative 7. that looks like it's going to be the positive 2 and the negative 9 that'll do that. So 3x squared plus 2x minus 9x is the split, minus 6. Again, I have a third term that's negative here, so be careful when you're grouping. Plus in between the parentheses, put the negative inside. I can divide the first two by an x. So my GCF is an x there. 3x plus 2 would be what's left over. The second two both are negative, so I want to take that out. 9 and 6 are both divided by 3, so negative 3 outside. That would leave me with positive 3x, positive 2. And I have factored my trinomial. So, depending on whether your lead coefficient is a 1 or something else, that will determine whether you're going to use split the middle term if your lead coefficient is something other than 1, or it's just as simple as sum product if your lead coefficient is 1. So those are the methods you need to know to factor trinomials.